Hi, I'm Tanner.
And I'm Tito, and we're with HiddenLayer, a cybersecurity organization dedicated to securing artificial intelligence in all of its forms: generative AI, agentic systems, and predictive models. We developed the AI security platform to be able to secure every stage of the MLOps lifecycle,
Which includes supply chain, runtime, continuous testing, and security posture management.
The unprecedented rate at which organizations are deploying artificial intelligence is creating significant risk. When you build and deploy AI systems to make them available to your customers and to the public, you make them just as available to threat actors. Threat actors are poisoning models, injecting malware into them, and distributing them with backdoors.
The AI security platform is made of 4 modules: the model scanner, AI detection and response, automated red teaming, and the security posture management, which is our model inventory. The model scanner is going to be able to plug into the CI/CD pipeline to give you the supply chain security. AIDR is going to be our runtime module that's going to be able to monitor and detect any kind of threats against your AI models. Our automated red teaming will also be able to test and validate in the CI/CD pipeline, as well as validate post-deployment. Our security posture management is going to tie all of this together in our model inventory and give you the security status across all of the models.
You can think of the model scanner a lot like antivirus for AI. We're going to make sure that the model file itself is safe. There's no embedded code, there's no embedded malware, there's no signs of poisoning, and the model is what it's purporting to be.
With the model scanner, we scan the serialized artifacts and any of the dependencies to make sure that there's no known vulnerabilities inside of your models. We scan 30 different model frameworks today, which includes older formats such as Pickle, PyTorch, TensorFlow, but also newer formats such as ONNX, GGUF, NVIDIA NeMo, and all of the newer frameworks coming out.
Data scientists are bringing pre-trained models into your organization from many different repositories, assuming them to be legitimate.
In order to develop faster and get more models out to production, data scientists have started to bring in models from third-party repositories. This introduces the risk and the need for the model scanner.
The HiddenLayer model scanner allows you to make sure that these models are legitimate before bringing them into your organization.
Inside of the model scanner, we'll give you a bunch of information around the categories that we'll scan for, the files that we scanned, and any kind of framework that we're associating those detections with. At the top, you'll see the detection summary that'll give you information on the number of files that we scanned, the version that was scanned, and the version of the scanner that it was scanned with.
In this model, you can see that we identified arbitrary code execution, but we're also scanning for arbitrary read access, denial of service, embedded payloads, suspicious functions, network requests, decompression vulnerabilities, directory traversal, and any abuse of the graph payload.
So in this view, we can see the file that actually has the detection associated with it. So we can see the criticality level here, the description of what we've identified, as well as all the frameworks that we tie back to. So anytime we have a detection inside of the platform, we'll tie that back to the MITRE ATLAS framework, the OWASP top 10, and then here in the model scanner specifically, back to the CVE and CWE database.
If you want to test a model before bringing it into your environment, you can use our community scan.
With the model scanner, we have the ability to take in the URL and scan any models that are publicly available. This allows you to test and scan the model in our environment before you bring it into your environment.
Now that we've established that the models are clean at a code level, our next module, AI detection and response, secures these models at runtime.
When AIDR is deployed and monitoring these models, you get an auditable log of inferences of who's using your model, how they use the model, and when they're using the model. You can see information around metadata around the input and output layer, as well as context around each interaction with that model, which will then dive into the detections. AI detection and response looks for different types of vulnerabilities depending on the type of model. For traditional models, we're looking for adversarial abuse that has to do with building adversarial samples to bypass the models, as well as looking to steal them. On the generative side, we're looking for things like prompt injection, jailbreak detection, different types of data leakage, different types of denial of service, as well as refusal.
Within the console, you'll see the LLM Sandbox. This is an application we built to test those interactions so you can see how AIDR is working.
This gives you a single-shot chat interaction with GPT-4 where our product is running in our proxy mode, proxying OpenAI. You can change any basic policy to be skip, alert, or alert and block. Inside of the advanced policy settings, you can tune all of our detections, create custom patterns, and do anything that you need to customize it for your use case. First, we'll go through a prompt injection scenario. We'll go ahead and analyze here, and that'll come back and we actually hit a guardrail GPT-4, but you can see at the top here, we've detected prompt injection tied back to both OWASP and MITRE ATLAS, as well as external harms on that guardrail activation. Here you can see we do call out our detection latency. Since we are in line with the model, we just like to show that we are not adding any additional latency there. And we can see that we are at 18 milliseconds, and that's the sum of the input and the output checks, while we waited almost a second on the upstream model to return. We can currently see that our policy is set to be alert only, and that we detected prompt injection and that guardrail activation. And so if I go ahead and I change our policy setting to block prompt injection, and we analyze again, we'll now see we've received a message that says that it was blocked. we can see we have no upstream latency since we will not send it to the model anytime that a block policy on the input side is found. Next, we'll go through a data leakage scenario. We're going to ask the model to summarize an invoice that contains an IBAN code. We can see here that we've identified an IBAN code both in the input and the output. We tie that back also to OWASP again and MITRE ATLAS on data leakage. There's two kind of scenarios that we'd want to protect against here, which would be one, you have an employee that's going to be able to copy and paste this and leak externally, and so we can go ahead and turn on redaction. If we analyze again, we'll now get our response back and we can see that the IBAN code has been redacted back to the user. The second scenario is that you don't want your data to end up inside of OpenAI's training set. So we can go ahead and turn on block data leakage on the input side, analyze again, and we'll now see our response that we were blocked because of input PII.
For the sake of continuous testing, it's important to automate attacks against your models in the same way that threat actors would. For this, we use automated AI red teaming. With automated AI red teaming, you can test your AI applications with the same attacks that threat actors are using in the wild.
Inside of the automated red teaming view, we can see our targets here. When we set up a new target, we just have to point it at an application's endpoint. Then we can run the automated red teaming against that application and understand what it's vulnerable to. If we go into our attack library, we can see we tie all the attacks back to the OWASP top 10. Inside of here, we have subcategories that can help identify the risk and give you a way to mitigate that risk for specific use cases.
You can use these attack categories right out of the box, or you can customize them and combine any of that you like.
When you run the automated red teaming, we'll give you a high-level information on the attacks that were successful and which critically failed, and then also the categories that we found during the run. After the run, you'll receive a report. You'll be able to download the report, which will give you all the information about what was executed against your application. It'll show you the prompt and output from the model. It'll also tie all of that back to the OWASP top 10 category that was associated with and provide you that risk profile.
Within Model Inventory, we'll show you all of your AI assets. You'll get a card for each model, and you can quickly see if they're safe or unsafe. This is going to allow you to see all of the AI assets, auto-import all of your models from the different solutions that you're using, and understand where are all your models, what are they doing, who has access to them, and whether or not they're safe.
In the platform, we provide an aggregated list of all of your detections across the model scanner and AIDR.
Within our All Detections tab, you can see every alert across your entire environment. With the threat levels provided, you can prioritize and address threats inside your security operations team.
Inside of the integrations, you can see we can integrate with the CI/CD platforms, the MLOps platforms, as well as SIM tools to process all of our alerts and detections.
With our SIM integrations, your security operators can secure artificial intelligence in the exact same workflows that they're securing accounts, endpoints, your network, or anything else. By integrating the AI security platform into your existing tool sets, the model scanner can scan code in the exact same locations that your organization is scanning all other software, allowing you to secure artificial intelligence without any additional work required from your security team. With these tools, your data scientists will be able to deploy models securely, faster, and with more confidence. The AI security platform is the most holistic security solution on the market to secure your Gen AI, agentic systems, and predictive models. The platform covers the entire lifecycle of needs across AI: pre-deployment, post-deployment, continuous testing, and overall model security posture management. The platform is comprehensive, highly scalable, and mature. The AI security platform is actively being used by some of the largest enterprise organizations on the planet and large government organizations like the DoD and the intelligence community. We know it's crucial to secure artificial intelligence at the speed of innovation. With the AI security platform, organizations can adopt AI swiftly and securely.
Thank you for letting us share a solution with you.
Please visit HiddenLayer.com to see more of the demo, download our latest threat report, or engage with us further.